Okay, guys, I'm back with lesson 44 for you, so please go ahead and pull your packets out and let's get started on that. Lesson 44 is talking about addition of rational expressions with equal and unequal denominators. So the first thing, you don't need to take these notes here, but off to the side, I'm going to just write a couple quick notes for you to think about. Okay, so we know that if we are going to add together fractions, let's just say we have these two fractions. We know that since we have the same denominator, we can just put our numerators up here and add those together, and we end up with 3/11. So what about when we don't have the same denominator? Well, we've worked many problems like that as well. But here's an example. We can't find the sum of this unless we do get the same denominators. So how do we handle that? Well, what you guys have shown me you know how to do is you would say, oh, well, the least common multiple of 2 and 4 will give me the lowest common denominator, which happens to be 4. So I need to change this 1/2 into something with a denominator of 4. So I would simply multiply both the denominator, whoa, where'd you go? Both the denominator and the numerator by 2, right? Because really all that means is I'm multiplying my fraction by a value of 1, so it's not going to change the value, it just changes the way the expression is written. So now I have 1/4 plus 2/4, and we know that equals 3/4. Well, in algebra, with algebraic expressions that have variables in them, we're going to handle them the same exact way. So it's going to be kind of fun. So let's look at what we have here. The first thing in number 1, I want you to notice that our denominators all have a variable of x in them. The expression in the denominator is x plus 2. But what you notice is all 3 of these fractions have that same denominator. So I can simply put these together by saying, I'm going to write underneath it. Okay, I have minus and plus here. So I'm just going to make my numerator 12 minus 8 plus 3 all over x plus 2, which is going to be 7 over x plus 2. And that is simplified down to its final form. Okay, so we handle that just like a normal fraction. Let's look at number 2. Now, they have the same denominator too, don't they? 2b squared c, 2b squared c. So again, this is going to be fairly simple to put together. I'm going to have 3a minus 4. But what I want you to notice here, remember, these are like symbols of inclusion. So that's like, actually, it's kind of like all of these terms are in parentheses because they're inside the fraction. And I need to bring that up because this is being subtracted here. So when I subtract 2a minus 6, that subtraction sign is actually going to affect some of the terms here in that second fraction. So let's put the same denominator on the bottom here. So what does happen? Remember I said this looks like I have to distribute, doesn't it? So in order to get these parentheses dropped off, I have to take this something here and distribute it. Well, what am I going to distribute? Well, actually, if you think about it, we said to put an invisible 1 in there. That gives you a number. What you're really distributing is that negative sign, but it's a negative 1. Okay, because 1 doesn't change the value when we multiply, right? So it's very legal to put that 1 in there. Okay, so now I'm going to have 3a minus 4, and let's do the distributive property here. I'm going to have a minus 2a plus 6 all over 2b squared c. Okay, now I can combine my like terms. I have 3a minus 2a, which is a, and I have negative 4 plus 6, which is a positive 2 all over 2b squared c. And that's the answer to the second problem. But now let's go down here because I've got some problems here that have different denominators, and they're not numbers, they're variables. So now we have to look at this and think, well, what is the lowest common denominator here? Well, we've been talking about in lesson 43, we talked about how to find the least common multiple. So let's do that. So I'm going to list all of my denominators, because remember, the least common multiple is going to be my lowest common denominator. So let's list its primes or our variables, like we talked about in lesson 43. We list the variables in a way that shows they have an exponent of 1. Well, these are nice because they're already that way. I really don't even have to rewrite these, but I want to do it this way to help you see. All right, so we take every term that occurs the most, and in this case, x, y, and 2 all occur only one time. So my LCM is actually 2xy. So that means I need to make denominators of 2xy in each one of those fractions. Well, how do I do that? Notice in the first fraction, gracious, in the first fraction here, I have 3 over x right here. How do I handle that? I need to make this a 2xy down here. So I need to multiply this with 2y in order to make it a 2xy. But remember, whatever I do to the denominator, I must also do to the numerator. So in that fraction, we're going to multiply it with 2y in the numerator as well. On the second one, how do I make that y become 2xy? I'm going to multiply it with 2x. And remember, again, I'm going to do the same thing up top here. And then finally, the last fraction, I have 2 as a denominator, but I need it to become 2xy. So it needs to be multiplied with xy. And so does its numerator. So now let's do the math on that. So 2y times 3 is 6y. And I'm just going to write out each fraction separately first for a moment till we get all of these numerators re-expressed. But I do have 2xy as a denominator plus 4x over 2xy plus xy over 2xy. Okay, so now they all have the same denominator. And now I'm just going to add these together. So I have 6y plus 4x plus xy all over 2xy. There's nothing else that I can combine. I have a 6y is a y term, 4x is an x term, and xy is an xy term. So that is fully simplified, and that's your answer to that one. Let's look at the fourth and final example, and then we'll do a couple practice problems together, and we'll call it a day. All right, so here we have 3 parts to an expression. 2 of those are fractions, and 1 is a whole number. Your best thing to do here is make the 3 a fraction by putting it over 1. Now let's think about what is the least common denominator. Well, remember, the least common multiple is the same thing as your least common denominator. So let's list each one of these. So I have k squared, I have a jk, and 1, which we're not going to really worry about. You can put it there if you want. We know 1's going to be the only number there. All right, so remember when we have a variable with an exponent, we need to split those up so that they're multiplied together with exponents of 1. And we have j times k. So where do these numbers occur the most? That's what we're looking for. So let's write out our prime factors here. So in k squared, I see 2 k's. So we're going to grab those because there's only 1 in jk. So we have k times k. And I see a j down here in jk, and that's the only one. So we're going to grab it and put it down here. And then, of course, the 1. So what is the LCM? When I multiply those and put those together, I have k squared j. We don't really need to list the 1, do we? So there's our LCM. So that's what we need to change all of our denominators to. So we look at what we have. If it needs to be k squared j, Let's look at the first one over here. I have k squared, but it needs a j. So I'm going to multiply it with a j, but not just there, on the top as well. So what does this term now become? Let's go ahead and multiply that out. I have 4j on top, and I have k squared j. Okay, the next one, I have jk, but the k needs to be squared. So what do I need to multiply that with to make it jk squared? I'm going to multiply it with k and its numerator. So this term now becomes, oops, I'm going to put my plus sign down here. So now I'm going to have 5k over k squared j. And then finally, the last term, I'm going to put my plus sign down here, is a 3. How do I make my denominator there jk squared? Well, I need to multiply the whole thing with it because it's not there at all. And then the top as well. So I now have 3jk squared over jk squared. Now you might be thinking, well, now I can cancel jk squared in that third term, but we don't want to do that because we don't want to get rid of it. We need our denominators to be the same. And if you notice, I am actually going to make one quick slight change right here. I'm going to actually put the j first, jk squared, so that the j's first, Hij should come ABC order. Okay, so now I have the same denominator, so I can write jk squared as my final denominator, and I'm going to put together what I have up top. And I have 3 different terms. I have a j term, I have a k term, and I have a jk squared term. So they're all separate, so now I'm just going to write them on the numerator by putting them together. And that's your answer. Okay, so this is how you use your LCM in a little bit more complex algebraic expression. Let's look at an example together. And this is going to come from your books on page 179. Down in the practice set, there are 4 of them down there. We'll do the first one together. Oh, no, let's not do the first one together because actually those have the same denominator. So all you're going to have to do on A and B, notice that the denominators are the same. You're just going to put them together just like you would any normal fraction. Okay, so let's do C. C is going to be a little bit more tough. We have x over m to the third plus 1 over c to the third plus a over m to the fourth. Okay, so none of those denominators are the same. So we need to figure out how to make them the same. So off to the side over here, let's go figure out our LCM. Let's list what we have. We have m to the third, we have c to the third, and we have m to the fourth. Let's break up m to the third as m times m times m. C is going to be 3 c's, and m down here, m to the fourth, is 4 times. Okay, so remember we're looking for the most occurring terms. So let's start with c. There are only 3 c's right here, so we know we're going to need that. And then also we have 3 m's with m to the third and 4 m's with m to the fourth. So we're going to find where it occurs the most, which is with m to the fourth. So then your LCM is going to be c to the third, m to the fourth. That's what you need to make your denominators. That's also your lowest common denominator. So I need to go back up to my problem and figure out how can I make each one of those terms turn into c to the third, m to the fourth. So let's look at the first one. The first one is m to the third, but it needs to be c to the third, m to the fourth. So what needs to be multiplied there to turn it into that? We need to multiply it with a c to the third because it lacks that, and 1 more m. And we need to do the same thing up top. So it needs to be c to the third, m. Okay, and then I'm going to go ahead right down here and rewrite this. So we're going to have, if I put them in order, I have c to the third mx over. Now, I'll go ahead and put this down here, c to the third m to the fourth plus, now let's look at the next term, 1 over c to the third. It needs to be c to the third m to the fourth. Well, you've already satisfied the c to the third, so we need to multiply it with m to the fourth. Denominator and your numerator. So let's rewrite this expression now. So we have m to the fourth up top, c to the third, m to the fourth on the bottom. And the final fraction, this needs to turn into, we have m to the fourth, but it needs to be c to the third, m to the fourth. So the only thing it's missing is c to the third. And we're going to multiply it with that along with the numerator. So up top we have a c to the third over c to the third m to the fourth. Now look at our denominators. They're all exactly the same. So now we can just combine this fraction. So we're going to have c to the third mx plus m to the fourth plus ac to the third all over c to the third m to the fourth. There's no other terms that are alike that we can combine. So we're done. And that's that answer to that problem. So you're going to go ahead and finish A, B, and D. Again, you can find those on page 179. It's the practice set there. So finish those up. I'm going to write down what the answer needs to be, so you can check it to see if you get it right, but you do need to show your work. It's not going to be accepted if you just have an answer here, so please make sure that you do the work. I'm just giving you the answer so you can check it. All over p to the third. Okay, so good luck with those, and then you can move into your lesson and finish that up, and I will see you next week. Thanks for watching.